Hello, welcome to Reimagine Learning's course on technology selection. This is part of our set of courses on system design. This is Akshat Verma, uh, teacher, engineer, architect, CTO, and I'm going to talk about technology selection and how important it is in terms of creating a system design. So in the previous set of courses, right, you've covered functional design, which is essentially the first step in building an end-to-end system. Functional design essentially defines all the components that you need to meet the functional requirements of a product. Technology selection is the next step, where for every component we identify the appropriate technology that should be used to build that component. So what exactly is technology selection? So in terms of technology selection, right, I mean, it's a very vast area, and every system, right, you will actually be making some unique technology choices. But there are some parts that are common in a large number of systems, and that is what we will cover. One of the most important things that people worry about in technology selection is database selection. Databases are fundamental to any system. And the obvious questions that come in our mind are essentially whether one should use a SQL system or a NoSQL system. Now, a SQL system has been the traditional answer for a long time, but in the past few years, NoSQL has really picked up. But there is no answer that's right all the time, and depending on the context, you need to pick SQL or you need to pick NoSQL, and that's going to be a very, very important decision for you to make. Similarly, you can look at workloads and classify them as OLAP or OLTP. And depending on that, your choice of systems differ from either being a row-oriented system to column-oriented system. That's another important aspect of data selection that you essentially need to take care of. And finally, you sometimes need specialized databases. Sometimes you need to essentially search based on free text. Sometimes you need sets. Sometimes you need objects to be accessed completely as one unit. And such essentially you have a lot of different specialized databases like a Redis, which is essentially a data structure data store, and Elasticsearch or Solr, which are essentially in text indexing engine. And then you have object stores like S3. Once you have selected the database in a large number of applications, you also need to go and create a data lake. So what you need to understand is, do you really need a data lake or do you need a data warehouse? Essentially, we need to fundamentally understand the difference between a data lake and a data warehouse. And then for data lakes, right, we need to build reference architectures. And those are some of the things we will cover in this course. The third important aspect is essentially what kind of compute do you use? And traditionally, you only had servers that you essentially could use to run your compute, but now you have a lot of choices. You can run VMs like an Amazon EC2. You can run containers. You can run your application within an app container like a Google App Run or an AWS App Runner. And then you have Lambda functions, which are completely serverless and essentially perform only one request at a time. So for your application, on a component by component basis, you need to figure out which compute platform should you host your compute on. And then finally, a very interesting question that a lot of architects worry about is essentially when do you put a cache and when do you not put a cache. In caching, it's also important to differentiate between when you're caching an external API so that you essentially save on response time, and when you're caching, putting a cache layer, in-memory cache layer on top of your database. And the kind of trade-offs you need to make between these two are very different. The biggest problem in caching is how do you ensure that your cache is coherent with your master? Your master could be, again, an external API or database. And those are the aspects that essentially we will touch upon in this course on when you should cache, under what context, for what use case, what is the right caching approach, and how do you actually maintain cache coherence. So that's essentially what we're going to cover in technology selection. 4 different aspects: database selection, designing a data lake, picking the right compute platform, and then making various decisions on whether you should cache, and if yes, then what approach you should take. Thanks for your time.